Hi Year 12, this is Mr. Seo. So today, this video is on section 1C. So this is all about geometric progression, or in short, GP. Now, the massive difference between an AP, which is 1B, and GP, which is 1C, is that in an AP, you see a clear pattern, and that is by keep adding what we call the common difference to generate the second, third, and fourth terms and so on. Whereas in a GP, instead of adding constant, instead of adding a common difference, we are now multiplying by a common ratio. So that's a huge difference. Now, a major mathematical tricks that's heavily used in this GP is index laws. So make sure, if you're still not up to scratch, go over and brush up on index laws from your preliminary maths. Okay, so some sample of questions that I've selected. These questions are starting with question 2. So you were told it's a GP, and the first term is 12 and the common ratio is 2. So to generate the first 4 terms, you just got to keep multiplying by 2. So 12, 24, 48, and 96. So we basically keep doubling the previous one. Part D, the first term is 18. The common ratio is negative third. So you multiply each of the first one by this to get the second one, and second one by the common ratio to get that, and so on. Okay, so pretty easy. All right, so question 3. So this time you're given a progression, all right, and you got to confirm whether that is actual a GP. So that means you need to work out the ratio. So ratio, just like in the common difference, in the common difference, you go from T2 minus T1 and see if it's the same with T3 minus T2. So this time though, you go T2 divided by T1 and see if that's the same with T3 divided by T2. Okay, so then as you can see, it's the same as 1 on 10 or 0.1. So hence it forms the same ratio. Hence it's a GP, with the first term being negative 1,000 and the common ratio is 1/10. Okay. Part G, well, this, if you have a look at the ratio, it's 4 between T2 and T1, and between T3 and T2, it's 9 on 4, which is clearly not the same as 4. Hence, this is not the same ratio, hence not a GP. Okay. Question 4. First term is 300 and the common ratio is given as 0.1 or 1 on 10. So then Tn, the formula then will be the first term times the common ratio, raise it to the power of n minus 1. Now, again, the important thing to note is that notice there's no brackets. So that means that n minus 1 is only effective for r only. So you have to think of that as a times r to the n minus 1. So a doesn't get raised to the power of n minus 1. It's a stands on its own. So a times, not a bracket there at all. Okay. All right. So 300 times 0.1 to the power of n minus 1. And you're asked to find the fourth term. So notice it's the Tn. The nth term is n minus 1. So it's not the 4 you're putting in there, one less. So it's going to be cubed. Okay, so then it becomes that. All right, so 3 on 10 is the fourth term. All right, next set of questions, starting with question 7. Okay, so you were told that it's a GP as that has the following sequence. All right, so clearly then the ratio is -3, and the first term, as it says there, is 10. Okay. All right, the nth term then will be the first term, a times r, which is the common ratio, raise that to the power of n minus 1. Okay, hence the sixth term then will be 10 times -3 to the power of 5. Now, it's got the odd power, so negative still stays there, all right? So then it's going to be that, you can use a calculator at that point. And T25 obviously then will be that one. Now, don't even bother using that as a calculator because it's a huge number, so you can just leave it like that, okay? And obviously the nth term will be that one there. All right. Okay, question 10, part F. So that's given, that's the sequence. And as you can see, the ratio is 1 on 5 divided by 1 on 25, which is 5, right? And the first term is 1 on 25, hence this is a GP, okay? All right, so that's the T2 divided by T1, that's T3 divided by T2. Both are the same as 5, so that's hence it's a GP. Hence we can write down the nth term, or the general term, so which is that A times R, which is 5 to the power of n minus 1. Now the trick that I've done in here is, because I can see that that's the base of 5, and I know that I can express 1 on 25 as the base of 5. So this is what I meant by the index laws. You have to be really stay up to date with all the index laws, okay? So 25 is 5 squared, it's 1 on 5 squared, so reciprocal is always the negative index, so 5 to the negative 2, and you can add those two to get that, okay? So that's the nth term. Yes, you are expected to go from there to there. Don't leave it like that, okay? Because you can all simplify that with in terms of 5. So you do have to go from there to there. You should be able to do that. All right. Then next part is, okay, work it out when one of the terms in the sequence is 625. Well, we know that the nth term formula, so 5 to the n minus 3 is equal to 625, and we know that 625 is 25 squared. In terms of 5, it'll be 5 to the power of 4. Hence, I've now matched the bases, so the indices must be the same. Hence, n equals 7. In other words, it's the 7th term of the sequence, which is 625. Question 11, part B, part 2. It's a GP with the first term as a 1000 and 7th term as 0.001. Okay, so nth formula then will be this. Notice we don't know the common ratio, and you have to work it out using this information. So 0.001 is equal to that, and now it becomes as an equation solving for r. Okay, so that means r to the 6th is equal to that divided by 1000. Okay, express everything in terms of 10, so that's 10 to the negative 3 and 10 cubed, using one of the index laws, the second one, the first one, whatever that deals with the division, and with the indices you subtract. So that's that one. Okay, all right. So it's r to the 6th. So you have to make somehow that in terms of something to the power of 6. Well, that's this, all right, and 10 to the negative 1, and outside 6. So r has to be, notice it's got to have a plus or minus because the power is even. Okay, so even power of the negative is still positive. So, and the question doesn't even say that there's no restriction given to the ratio. Okay, if the question says the ratio has to be positive, then yes, you can drop the negative sign there, but it didn't. So therefore, you're gonna have to include both, which is two possible answers for the common ratio. Okay, plus and minus. All right. Okay, so the last three questions for the day. Question 16, still a GP, obviously, and these form, so in other words, there's a common ratio there to work, and that's going to be the second term divided by the first one, or the third one divided by the second one. Whichever way you do it, you're going to get y on x, and obviously the first term is negative x on y, and use the formula, then you get this. Now, if you've see, I've decided to express x on y, okay. You can have two different versions to the answer, which I'll show you both, but I've decided to keep it as x on y, so that means I'm going to need to put that y on x in terms of x on y. Well, that's just a reciprocal, so that's x on y to the power of negative 1, but inside power and outside power, When you have a composite of powers, you can multiply them. So -1 times bracket n minus 1 gives you 1 minus n. Okay. So why did I do that? So that I can now have the same bases. So I can add those two indices. So that's 1. So 1 plus 1 minus n is 2 to the 2 minus n. Okay, and then negative outside because that belongs there. All right. Okay, so that's that one. But if you decided to flip y on x, then your answer will be that. Okay. All right. So it doesn't matter whether you have x on y or y on x, as long as you keep yourself consistent with the indices. Okay. Question 17. So that's the sequence, and you were told that sixth power is 3 to the 6. Okay. So the nth term then will be the first term times the a, right? Sorry, the common ratio to the power of n minus 1. The common ratio is 1 on x squared, so that's x to the negative 2. And again, index laws. So heavy use of index laws, I said before. You have to completely be up to date with the index laws. All right, can't stress that enough. So x to the 4, multiply those two to get that, and you now add those two to get this. Okay. Now, sixth term is 3 to the 6, so that's that one, and you substitute that n to be 6 because that's what it says. If it's nth term, then you put the n there. So that's this, and x to the negative 6. Same sort of thing going on with the previous, what happened in the previous question. So 3 to the 6, that's x to the negative 1 to the power of 6. So that means 1 on x equals plus minus 3. Hence x equals plus minus third. All right, so because you have the even power again. Okay, so you could have both answers for that. All right, question 19. So fx, it's a function now. So 4 and 25 times 5 to the x. Express 25 in terms of 5 so that you get this. So actually I can re-express this as that. Okay. All right, f of 1 is that. F of 2 is just substitution. So we can see that these numbers form a sequence, in fact, a GP. So then you can work out the common ratio as that one. Second term divided by the first term, which is 5. And the first term is obviously 4 and 5. So using the nth term formula for a GP, then you get this, a times r to the power of n minus 1. So again, expressing this 1 on 5 as 5 to the negative 1, and collect all the 5s, then you get this. Okay. All right, so that about does it for this 1C video, and I'll see you guys next time.